What's up, Math Maniacs? This is your boy, Mr. Bergman here, coming to you with section 1.2, day 1, 1.2a, evaluate and simplify algebraic expressions. Okay, so check out this cool little nifty picture I found. I really like it because all these vocabulary words that we've got here, they're going to show up in this picture somewhere. So for example, an expression, that's the first thing right here. This whole big blue box is an expression. And although it's not circled in here in blue as well, the other side, 7m plus 82, that's also an expression. What's an expression, in math at least? It's a collection of operations, numbers and constants, and variables. There are no equal signs. So you can see right here in this blue box, that's what exactly you have a collection of. Operations like multiplication and exponents, and then you got numbers or constants, like 82 is a constant or a number, and then variables also. So you're going to collect them all together, and that's an expression. What's a term? A term is a part of an expression separated from other terms by addition or subtraction. So you can see in green right here, this is one term. It's actually three terms in this entire expression. 52x squared is a term. 9x is a term. 36 is a term. 7m is a term. 82 is a term. So three terms over here, two terms over here. That's what a term is. And an equation is just an expression equals an expression. You got blue expression over here and then unboxed expression over here. Expression equals expression. What's a power? A power is a number or variable, which is, we'll call that the base. And then it's multiplied several times, and we'll call that the exponent. So, and anytime it's an exponent of 1, kind of optional to write the 1, as you can see right here. So if we want to evaluate, check this out. So I got a nifty picture. So you can see base is 7 in red, exponent is blue, the 3, and the whole thing together is the power. And what that really means is just repeated multiplication, 7 times itself 3 times. So there's a little tricky thing that lots of people forget about. It's with the negative. So you can see if you've got an exponent outside of these parentheses, that means you're going to write -5 4 times. Well, that's what it means. So -5 times itself 4 times. Since there's 4 negatives, they all are going to pair up and cancel out. So the overall answer is going to be positive 125. However, if there's no parentheses, then the exponent does not apply to the negative symbol. This 4 only applies to the thing that's closest to it, which is this 5, and the negative only gets considered once. So you've got 5 times itself 4 times, and then you bring along the negative for the ride. Again, 5 times itself 4 times is 125, and then bring along the negative. This answer over here was positive. This answer over here was negative. Next thing, order of operations, PEMDAS. Let me hear you say PEMDAS. Yes, parentheses, exponents. Then multiplication, division from left to right order, and then addition and subtraction, again from left to right order. So what does that look like? Over here, you can see if we want to evaluate, then evaluate just means like turn it into a number, give a number, answer. There's a whole bunch of operations going on here. I see addition, subtraction, multiplication, and an exponent. Which one do I do first? I do the ones that are inside the parentheses. So you see 5 minus 3 is 2, and I'm going to make one change and recopy. Super important habit. Make one change, recopy. Again, now that I've done everything inside the parentheses, next thing I'm going to do is the exponent. So 7 squared is 49. Make one change and recopy. Then, am I going to do the addition next? Nope, I'm going to do the multiplication or division first. So 49 times 2 is 98, and then lastly I'll do the addition, and I'm reporting my answer, my numerical answer, which is what evaluate means. Alright, so the next one over here. Wow, there's a whole bunch going on, and I think I've got to do what's inside the parentheses first. So I see subtraction and multiplication inside the parentheses. I think I got to do the multiplication first. Make one change and recopy. 6 times 2 is 12. And it's the only thing I change. I'm going to rewrite the whole thing again. That's the way you stay consistent and 100% like do your very best work. Is no shortcuts. Make one change and recopy. You might think it's a lot of handwriting, but I'll tell you what else is a lot of handwriting. Doing a problem wrong. Writing out work just to get the problem wrong. That is an entire waste. So let's do a little bit of handwriting and then let's get it right. So next thing I'm going to do is the exponent. Oh no, sorry. Inside the parentheses, 10 minus 12 is -2. if you want, you could change that to 10 plus negative 12, and so then you can see that because subtraction is always super tricky. 10 minus 12 is negative 2. Turn it into 10 plus negative 12, you can see that when you're adding, the same, you've got different signs, so you got to subtract 12 minus 10 to get 2, and then keep the sign of the bigger number, and then it'll be exact. That's negative 2. Anyway, so now I've got all this going on here. I've finished everything inside the parentheses. There's no more operations to do because this is a negative sign as opposed to this subtraction. Super tricky. Anyway, the next thing to do is the exponent, so 3 squared is 9. And now I've got a whole bunch of subtraction and addition. What am I going to do next? I think actually what I'd rather do, to be honest, is subtraction always bugs me out. It's no fun. It's a lot more reliable to do addition. So I'm going to actually change the subtraction to subtraction. I'm going to keep change flip. So keep the 20, change the subtraction to addition, and then flip the positive 42 to a negative 42. So 20 plus negative 42 plus negative 2 plus 9. Now, PEMDAS says that if you have a whole bunch of addition and subtraction, you got to do it from left to right in order. However, another thing that is also true is that we saw a couple sections ago that addition is associative, meaning if you have a whole bunch of things to add up, it doesn't really matter what order they are. It's only if you're blending addition and subtraction, like up here, you are 100% required to do this subtraction first before you do this addition. But in this case, if you wanted to, you could do them in any order you wanted to because they're all now addition, which is a lot easier. Anyway, I'm going to do the first. After all that, I'm just going to do 20 plus negative 42. And same signs add and keep, different signs subtract. Keep the sign of the bigger number, then you'll be exact. So these are different signs. And so then I got to subtract the actual numbers, 42 minus 20 to get 22. And I'm keeping the sign of the bigger number, which is over here. So this is negative 22. Great. Next one. I'm going to do these two first. So same signs add and keep. Oh, they are both negative. So I'm going to add 22 plus 2 to get 24. And I'm going to keep the negative. Same signs add and keep. Boom. Now here I see different signs subtract. What is 24 minus 9? It's 15. I'm going to keep the sign of the bigger number because then I'll be exact. All right, next. And if you don't know that song, we're going to sing it in class for sure. All right, so here's the new thing. When x is equal to 3, it basically wants you to evaluate this. Like if you're going to report a number answer to evaluate, then you have to use this x equals 3 as substituted in. And that's the one change you're going to make. You're going to recopy the whole thing, and instead of x, you're going to write a 3. And I like to use parentheses anytime I'm substituting. All right, so I see multiplication, I see subtraction, and addition. What I'm going to do, I'm going to multiply first. 4 times 2 is 8, and bring down the negative. And now I've got a subtraction and addition. What do? I'm just going to change the subtraction to addition. So you see, negative. I keep the negative 8. I change this subtraction to addition, and I flip the positive 18 to a negative 18. Negative 8 plus negative 18 plus 11. And now, same signs add and keep. These are the same signs. They're both negative. So I'm going to be 8 plus 18 is 26. Keep the sign of the bigger number, which is 18. And you got negative 26. Negative 26 plus positive 11. Same signs add and keep. Different signs subtract. So we've got 26 minus 11 is 15. And keep the sign of the bigger number, which is negative 26. Boom. There's your answer, negative 15. Let's do it one more time. Check this out. Check this wild, complicated expression here. Every time we see an x, we're going to write a 2. Every time we see a y, we're going to write a 5. Remembering that there's actually multiplication. It's not typed out here. The x squared, it's actually times y, and x times y squared, 3 times y. And so I inserted a whole bunch of multiplications to make it really visible here. So this is really going to be 2 squared times 5 minus 2 times 5 squared plus 3 times 5. All right, let's get rid of those exponents. Make one change and recopy. 2 squared is 4. 5 squared is 25. Is that really 2 changes? That's fine. Next, I'm going to do the multiplication. So 4 times 5 is 20, 2 times 25 is 50, and 3 times 5 is 15. And then I'm going to change the subtraction to addition because it's just a lot easier for me to think about. So we got to keep the 20, change the subtraction to addition, and flip the positive 50 to a negative 50. 20 plus negative 50 plus 15. Different signs, same signs add and keep, different signs subtract. These are different signs, so I got 50 and 20. I'm going to subtract them. 50 minus 20 is 30. I'm going to keep the sign of the bigger number, because then I'll be, ooh, maybe you can tell me, what is negative 30 plus 15? Well, I think those are different signs, so I'm going to subtract the 30 and the 15, and then I'm going to keep the sign of the bigger number. So why don't you tell me what that is? And just for your audio check, I just wanted to throw it out there that when I was a kid, I played 3 different instruments: the violin and the trombone and the drums. It was a lot of fun. And why don't you tell me what instruments you played, if any, when I see you in class? Take care.